Okay. We are at the top of the hour. There's still a couple people that I'm expecting who aren't here yet. So we might wait another minute or two. And then there's one person I realized did not actually confirm whether or not he planned to talk about his draft, but I had put him on the agenda. I don't see him here yet. Let's see. Oh, there's my apologies. The draft, the time and date.
You've just vanished from our audio.
The slides as well. The wonders of internet connections.
Oh, you know, I'm talking away and I had muted myself. I wonder why I vanished. Okay, am I back now?
Online.
Yep.
I have no idea why I vanished, but. All right, so it's 11:02. I think we should probably go ahead and get started. I think we have most of the people I'm expecting, except for one. Okay, so welcome to the NTP working group at IETF 110. This is the IETF Notewell, which you have undoubtedly seen a number of times and agreed to when you register. It has all of the processes and procedures, and then there's a list of documents and other BCPs that apply to IETF work. If you have any questions, feel free to ask Dieter or I or our AD, Eric, who is online. This is our agenda for today. I did not allocate time to each of these, and it got a little bit longer than I expected, so we'll have to keep an eye on the clock. The next thing, so Dieter has agreed to take minutes. Is there anybody else that wants to help him? No. And are there any agenda bashes? Nope. The next thing is NTP working group status, document status. We are making progress. The Yang data model has gone through last call. An updated draft has been submitted. And And I know that the editors of that are not available today. I believe that the work is between Eric and the chairs. Command modes, I just realized that we lost track of this one. And I believe Eric, it has been through last call. It has a discuss on it. And I believe that Brian has answered all of the questions. We decided on a way forward, but we have never circled back to Ben to resolve that discuss. So
I have track that I thought there were 3 things that were not yet resolved. I took some notes. I have a little bug tracking system. He was okay with the MD5 stuff as long as we reverted the status to historic, which we did.
right.
But there was a question of there's a 20-bit versus 24-bit field Ben felt was confusing, and I think there was 1 or 2 other points that I did not see any changes in the doc addressing that.
Okay, so I missed the fact that there was additional things that he needed addressed. So I thought that the latest update addressed everything. So that's a miscommunication.
I think yeah, I can send you and Brian my recollection of the notes and try to pick that stuff up. Ben did ping me a couple times saying, "Are you waiting on me? Are you waiting on me?" And every time I was dealing with other documents and other things. So
Right.
I don't think we're waiting on him.
Okay,
but I
so
can
we're not
send
waiting on. So
I can send you and Brian the what I believe is the remaining thing.
okay, that would be very helpful. Thank you. The port randomization document is moving through. It has been submitted. It has been reviewed. It's on its way. I don't think there's any big blockers there. I just went away from my data tracker window. Right, so that's with you. And then that leaves 2 that are ready for the IESG that need to be submitted. I completely forgot about the TikTok document, so I have moved it over to here so that we will do a better job of keeping track of that one. And the NTP interleave modes are ready to go. So we'll get those done right after this IETF. And with that, that is the end of our documents that we don't have on the agenda to talk about today. So next is, is the alternative NTP port. Miroslav, do you have anything you want to say about that one?
Yes, there is a new version that was submitted, but there were no significant changes, just few sentences reworded to make them more clear. There were suggestions from Stephen Summers. I think all comments from the mailing list are now addressed, and the draft is ready for a last call.
Okay. Does anybody have any questions or comments on this document? No? All right. So I think you're right. I think it's been around for a while, and we are ready to move it to working group last call. So we will do that after this meeting. Did Rich join us? I didn't know if he wanted to talk about this updated registries draft, but he is not in the, oh wait, he is here.
I'm here.
Yes, Rich.
Sure. So I guess I'm asking for working group adoption. What I did is went through all of the old V1, etc., NTP specs, pulled out everything that looked like a registry, wrote it all up because some of them were just sort of implied. Yeah, there will be an issue, I think, for discussion on the working group list Some of the NTS registries were partitioned into different spaces, but since, you know, it's like, oh, you can have the low order byte of a 4-byte field or something like that. It sort of reminds me of the old BSD reserved ports thing. So we'd have to resolve that issue, but other than that, I don't think there's any controversy. I did have IANA pre-review it just to make sure that it answered all the questions and fit what the current standards are for IANA requests these days. So that's it. It's a short doc.
Okay, so Marcus, you're in the queue?
Yeah, can you guys hear me?
Yes.
And possibly also see me in a few seconds. So I read through the document yesterday, and it all makes sense to me that we try and make sure we have the same sort of requirements and specifications for the registries. The only thing I'm missing here is a motivation for why we've chosen certain policies, such as, for example, specification required. I have no problem with picking that as a policy for all registries, but I'd really like to read a couple of sentences on why we picked that one.
Okay, yeah, exactly. You mean, sure. I just put it in because I've been one of the TLS designated experts for years, and it just seemed the way that more things were going. If we wanted, you know, the other advantage, well, yeah, I don't have a strong feeling one way or the other, whatever the working group wants to do. I know that's like sort of a not answer. It was just like arbitrary. Based on my experience, it seemed designated, you know, expert review was better. It could also, the experts could be given instructions to partition the space for only standards track things, having the low order port number, low order extensions, if that's really what we want. But yeah, not a complete answer, but the best I got so far.
Okay. Any other questions on this draft? Okay, so for this one, we're asking to adopt it as a working group draft. Is there anybody who sees any reasons at this point why we shouldn't issue the call for that? All right. Yakov?
Question is, assuming this is adopted, this is basically going to be an RFC, which is only an IANA considerations section?
Some of the history, I mean, the outcome of it is, yes, it's only IANA stuff, but it also describes what some of the fields are and gives a summary. So if anybody hadn't done all of the other reading or wanted to know how do I add an NTS extension, this would give them a chance to figure it out.
Yeah, I think we can make these changes as just an IANA request. We wouldn't really absolutely have to have a draft at all. But I think an informational RFC is the right way to go here.
So what the reason I asked it, first of all, I've never seen an RFC which has only an IANA consideration section. But what I wanted to suggest is instead have first several sections which explain what each of the parameters does, and then have a typical IANA consideration section which says IANA is instructed A, B, C, D.
So did you read the draft?
Yeah, I just read it right now. It It's
I mean,
mixed. It's not. Yeah, I agree. I think it's just rearranging the material that's there. It's not that there's something missing.
Okay.
Okay. Any other comments on this draft? All right, so thank you, Rich. We will do a call for adoption on the mailing list. Next up on the agenda is Chronos. Netta, if you want to, do you want to do your own slides or do you want us to share them for you?
Great. Share screen. Okay, how can I share on the screen?
If
Yes,
you want, I can.
I send you a request for a screen sharing. Okay, we can also do it with your.
I think I've hit
as well.
I've hit the green check mark. I think it's thinking about whether it's going to give it or not.
Oh, okay.
Let's see. How about now?
Yes. Hi everyone. And today I'm going to present the current state of our work and NTP security, the joint work with Dani Dolev, Tal Mizrahi, and Michael Shapira. Yeah, so a short reminder, we consider the following tweet model where the attacker has full control of larger a fraction of the NTP pool, so a quarter. He can change the content of the NTP responses and also delay them. And of course, the attacker is malicious and try to shift the client's clock as much as possible. As you can see in this picture, the client will receive, as you know, both good and bad samples, and he might choose the shifted one. Therefore, we suggest that the modified NTP client named Chronos with the following characteristics. It has a probable security, which means that we can bound the success probability of an attacker to shift time even for a minute in the middle. It has backward compatibility since there is no need to change anything in the NTP servers, and we are mostly based on the standard NTP client. And we add only small computation and communication overhead as we query small number of servers. And also a reminder of a home solution. Also, on the one hand, we use a big a pool of NTP servers. On the other hand, we choose at random only 10 NTP servers and sample them. And lastly, we use smart filters in order to remove outliers. Sorry. However, we found that Chronos has some limitations. First of all, it relies on hundreds of servers, which are not available in many regions. And the second is that it queries randomly selected servers, which might be dependent on each other due to NTP hierarchical architecture. And therefore, an attacker who directly controls even just few of them might influence many others. We quantify the influence of an attacker on the pool based on the number of servers he controls. So a server is influenced by an attacker, as you know, if the attacker controls the majority of the servers it's synchronized with. So here in the x-axis of this graph is the number of servers directly controlled by the attacker, and in the y-axis of each of these two graphs, the shifted or the influenced servers ratio out of hundreds. So, for example, in the figure on the left, an attacker who gains control over 20 of the most popular time servers in Germany can shift time of 52% of the time servers in this country. Similarly, controlling 44 time servers in North America is sufficient for shifting time or at 40% of the servers in this region out of approximately 900. So we can see that controlling a small subset of servers in a region gave the attacker the ability to shift time at many other servers. Therefore, we suggest, as it was published in the last NDSS this February, to add a new pool called Irankia, which avoid the dependency issues. The servers in Irankia should be Stratum 1 time servers, which are independent of each other. And to make it harder for the attacker to inject time servers, the servers in Irankia should belong to a reputable organization. And in the future, servers may be added by some trusted authority. Irankia should include hundreds of such servers for security reasons. However, the reliance on Stratum 1 servers only force us to use geographically dispersed servers, which may affect time and time currency and precision. Therefore, we propose that each NTP client will run simultaneously two parallel synchronization processes. The first one is primary process, which is identical to the one that is used today, such as the default NTP v4 or in the future NTP v5 client that synchronize with the pool assigned servers in this region. And the second one is a watchdog process that consists of Chronos clients, which synchronize with servers in Irankia. The time of the clients is the time in the client is updated by the primary process, unless it's there is time deviation between the client, the NTP-v4 client, and the watchdog time. And in this case, the client's time is updated by the watchdog. Now let's see how Irankia may affect the time currency, precision, and load balancing. So to measure these differences, we use clients in different regions to query NTP servers across other regions. For example, as you can see here in this figure, on the left, we place clients in the UK and query servers inside the UK pool, in Europe, US, and global servers. The gap between the offsets achieved by querying inside the UK and query on other regions was 6 milliseconds. And we got the similar results for clients in Ireland, Germany, and in the US. Following these measurements, we can configure the watchdog taking over only when its offset is far from the NTP's offset, like approximately 50 milliseconds. And we can see that this provides both good precision and security for the following reasons. In the absence of attack, Irankia offsets will be only few milliseconds away, even when using X-region servers. And therefore, in this case, Irankia will not be used, and the existing NTP clients concurrency and precision are maintained. Only when there is an attack, we expect to get large offset gap, and in this case, using Irankia will prevent time shifting. This way, we expect to get an offset within a few milliseconds from the correct time, even during an attack. And regarding load balancing, note that in the primary process, NTP before load balancing is used as this. We suggest that in the watchdog process, the query rate of Irankia servers will be much lower than the NTP query rate. More precisely, considering that only around 10% of the NTP servers are Stratum 1 servers, the query rate of watchdog should be respectively lower. And here we show the lower bound of the expected time of successful time shift. When we consider an Irankia pool with a 200 time servers when the watchdog queries 12 of them every 10 hours. And even after an extreme case where when many of them this service in Anarchy are controlled, 7 of them are controlled by the attacker, shifting time at the client by a 1.1 millisecond, for example, from the UTC will take the attacker at least 26 years in expectation. So to conclude, we consider that an attack strategy of exploiting inter-servers dependencies. We empirically quantified the impact of this attack and showing that it can cause significant harm. Finally, we propose a scheme for improving NTP security within Anarchy, which will preserve today time accuracy, precision, and load balancing. So in draft 02, in the last draft, we addressed the comment we got from the working group regarding the watchdog mechanism and its default parameters. And we thank Olish and Watson, and I hope I pronounce this name well. Sorry if I haven't, for useful discussion. And next, we will update the draft to include an uncased pool option. And we continue to work on implementing Honus as a watchdog of NTP4, and we continue to evaluate Honus and Inanke performance and security. And that's all. If you have questions.
Okay, Anastasia?
Okay.
Ignacio, can you go ahead?
From recursion here.
Go ahead, Ignacio. Can you all hear me?
Yes.
You
I
can't
can.
hear Ignacio.
Ignacio, we'll come back to you. Watson, do you want to go ahead?
Yeah, so what you presented is different from the draft. That's fine. But once we start getting into saying we're going to deploy servers around the world that we trust, that is effort that could get you much stronger security guarantees if they were running runtime, and if they were running NTS as well. So it seems that once you're putting Inanka in, the relevance, and the other thing is the issue with the query rate isn't well-behaved clients. The issue is that any NTP server you operate can be abused. And the demands of serving for a huge amount of, well, huge by 90 standards amount of NTP traffic aren't that great. So at this point, when you have these trusted servers around the world, you start thinking, okay, why do I even need them?
Again, what do I even?
So for the performance that we've seen with sort of the Cloudflare NTS server, which is publicly available, is that it can serve hundreds of thousands of requests over on one core. And once you have its volume, a server is going to serve tens of millions of requests a second. This is without any special effort. So at that point, you're serving billions and billions of clients from a single server. Do you really need the record?
Okay, I hope I hope I understand the question, but it seems like what you are asking is that if you are using an Anki pool, and we all know that it's more secure and so on. What do you need a Cronus at all? But as you were saying, every server can be attacked. So this is why I think that if we have Cronus and if we are going to use Watchdog anyway, so why won't we double the security that we can have, which means both using more secure servers and use the Hono's algorithm for dropping outliers among this group. Does that answer your question?
Go ahead, Watson. Did you want to respond or?
Yeah, sorry, I didn't quite catch that, but yeah, I think it's something that we'll discuss in the list, and once the next
Okay.
draft comes out, we see exactly what the proposal is.
Okay, that'd be great. Inacio, do you want to try again, you said? Oh, he's going to write in the chat instead, I think. Oh, wait, no, go ahead. I think he's going to chat.
Okay.
All right, so next up is, are there any other questions for Netta? Nope, okay, great. So
Thank you very much.
thank you. So Watson, rough time, did you want me to do the slides or are you going to do them?
For this here screen request, you should present the slides, and I'll just. Okay, everybody can see me. Everybody can hear me.
Yes.
Great. Thank you for sharing the screen, so I don't have to fiddle around.
Okay, just give me 2 seconds to make sure I have what I need. All right.
All right, so I'm going to be talking about the new rough time draft. Next slide, please.
And your audio is
So
going wonky.
first, my audio is going wonky. All right. Well, I think we'll just have to deal with it. I'll try not to touch the table.
Maybe switch off your camera for a moment to see whether that fixes the audio.
It's bad before.
Okay. Now is it better?
At all.
No. All right. Okay, I can try a different microphone. Is this better?
That's perfect.
Okay. Weird. All right. So next slide, please. So rough time is certificate transparency for time. So the idea is by having servers sign their responses, we can detect cheating. We can detect time that is invalid within the limits of the round trip time. This solves real problems. It solves real problems for certificate verification in browsers. It solves the bootstrapping issues where we need an authoritative source of time independent from X-Avalanche certificate verification. It has been, early versions of it have been adopted and have seen real use in Ethereum v2. Sorry about the audio issues. I think I can't think of anything else to try. Now on the internal, try the other mic. So it's been adopted, the early versions have been adopted and seen real use in Ethereum v2. Next slide, please. Next slide. So we split the draft and into two drafts now, and the question is why? So the first draft is IETF rough time 004. This defines the wire format. How clients request time, what server sends back. It's stable, if achieving interoperability, has hackathons. Hopeful advanced working group last college draft or 5 years. Type things that need this one.
Your echo is
Look at it. I don't have it, so there's no feedback. All right. this better?
For now.
Okay. All right. So, okay. I think I know what the problem is. I'll fiddle with it later. But what's working now is working. And so this is, so draft-03 is going to be our interop target because there's no wire changes we think we need to make. The changes have just been editorial. Then the second draft, which is much less advanced, is draft IETF NTP runtime ecosystem -00, and it defines a broader ecosystem of how do clients report on malfeasance, how do people check that servers are actually operating correctly, trust, what are the trust anchors, how do you define them? There's much more work needed here because there's a bunch of serialization formats that we haven't thought about before, and like certificate transparency, this is an ecosystem. It needs deployments, it needs independently operated servers and checkers, and this can update much more independently because servers do not need to make any changes, no matter what changes we make to the ecosystem parts. Clients might need to make small changes, but they don't really. If you have any sort of format to store your trusted server list in, that will work for you, and later you can update to use a more standardized one for interoperability purposes if it makes sense. You can always take advantage of the checkers. Once we have those defined, the existing server base will work. Next slide, please. Other changes, so Marcus is now a co-author. It's extremely possible that when I was chopping these apart that I made mistakes and sentences don't make sense anymore, there are sections missing. There have been typo fixes. There are always going to be typo fixes. So that's most of the other changes. And now last slide. Are there any questions for me?
Any questions? Okay. It has been pointed out that perhaps I should have done a call for adoption for the second document. So I'm asking now if there's any opposition to us having just accepted it as a working group document as a split out of the first document. I was assuming since they were one document on the topic, we were just making it two was not an issue. So
Yeah, I mean, I don't see that we need a CFA for that at all. We've adopted the first document. The editors decided to split it into two. It's now two working group documents, as far as I'm concerned.
okay. All right, so these documents are progressing. If anybody has any comments, please take them to the mailing list. Next on the agenda is a presentation or topic that came from the dispatch meeting yesterday. And do you want me to show your slides, or are you going to just speak to the document?
Hello, do you folks hear me?
We do, yes.
Okay, perfect. Thank you. If you can share my slides, that'd be great. Otherwise, I can try to initiate.
Okay, I'll get there. If you want to go ahead and start talking, I will.
Oh, okay. Yeah, sure. Hello, everyone. Oh, great. Okay, sorry, right?
I'm so close. There you go.
Okay, I see them now. Thank you. Hello, everyone. And I'm Ujwal. I work at Igalia. And I've been working on this format for expressing dates and times on the internet, which is something of a solved problem, if you ask many, but it's not completely solved yet, as I'd show in the next few slides. If you could progress just a little bit. Yeah, so before you ask, I am a delegate of ECMA TC39. We've been standardizing different additions to the JavaScript language, one of which is called Temporal, which is what I'm working on. It is a ergonomic API for dealing with dates and times. It's something that we've worked on for the last couple of years, and it introduces new ways to think about dates and times in ways that we've not discussed previously. So that's really interesting. The problem that we come up with once somebody deals with time zones and calendars as sort of first-class objects is how do you include that information during persistence, right? And if you progress these slides a little bit, we have this as the okay, yeah. We have the format specified by RC 239, which is perfect for representing instance in time, but any additional information is lost. And this is a known problem. The time zone conundrum, as one might say, is different applications realizing that they need a human time zone in addition to the instant, in addition to the offset, and therefore adding a time zone to that. If you see a bunch of databases like Postgres or Oracle, or just datetime APIs like Java, or Linux tools like the date binary, a bunch of people have come up with interesting ways to include that information, none of which unfortunately is in the standards rec. So it needs to be standardized. And what's more is I do not see the screen yet, but okay, can you progress one more slide? Okay, yeah, these are the different formats that people came up with, and if you go one more, yeah, so we need a generalized format to avoid more people coming up with this problem and trying to hammer their own extensions into things, right? There's so many things that can be expressed. In our case, there was calendars, and yeah, a generalized format would help people figure out the way to add more information in a cohesive manner. So if you progress to the final slide, I think. Yeah, just this one is good. So this is how we use the calendar extension, which is, on the left you see 3339 format, and then there's an extension for the time zone, which is, as I mentioned, not standardized, but I think it's common. You can find it on the internet. And then there's a version of the proposed extension that can be used to represent the calendar. So we've talked about it in Dispatch. We talked about it yesterday, and the idea is that we're going to charter a new work group called SEDate to discuss this and hopefully publish this as an RFC. It was brought to my notice that people here would possibly be interested in this, so I'd love to hear your thoughts and comments.
Watson?
Hello, sorry for subjecting you to the noise of my laptop's fans taking off. One issue is that the choice of calendar will affect the definition of day. And so then when you have a time, it gets very messy, because if you're representing another, there's calculations. They're also dependent on where on the Earth you are. So I think if you're going to add calendrical data here, it's going to be a huge, huge mess to convert. And you're going to need to put in location data as well.
Yeah, the idea is that the instant remains the same as specified by 3339. It's always the left part, right, in the green part in this particular slide. And any additional information can be expressed in these tags, but that doesn't in any way affect how you interpret the part in the brief. So the instant always comes from there, right? And that is, then you may ask, why do we need that information? Well, if you need to do any sort of arithmetic on the instant itself, then you need this information, right? If you want to add a bunch of hours to a timestamp, you might need to know the time zone. If you need to add a bunch of months, you need to know which calendar system the origin is. But yeah, it's the timestamp itself always remains in the Gregorian, the proleptic Gregorian calendar.
Okay. Carson?
Yeah, I think part of the confusion here is that there are actually different applications for date times. And if you all dump them into one big bucket, it's going to become very messy. So I think the NTP working group is mostly interested in something that I call actual time. So a time that actually can be mapped on a time scale, for instance, the NTP time scale or a related one, and is not subject to let's say, non-physical input. Well, okay, there are leap seconds, but in general, we can treat these times as actual time, whether they happened in the past or whether they will happen in the future. But then there is planned time. So if I'm going to meet on Christmas Eve 2022 at 4 p.m. with someone, there is no way to map that to a timescale because I don't know whether we will have daylight savings time next year or not. That is actually changing right now. So there is no way on earth I can make this appointment to a timestamp that is on its timescale. And the more you go into these things and then you start to discuss recurring events and all this stuff, the more complicated this becomes. And it's no longer about time, it's more about calendaring. And then, of course, there's the third thing, which probably most people here don't care about, which is remembered time, which is something that happened in the past, and we only have limited information about what time scale that actually was mapped to. So let's ignore that for the moment. But for actual time and for planned time, you actually have to have very different mechanisms because you have to know which part actually wins.
Yeah,
I put in a link to a document that may be useful to look at in this context. So in the CBOR working group, we are looking at a way to represent time that is a little bit more flexible than the time representations we already have. And I expect some of this to actually go into this document at some point. Parts of it are commented out in the current submitted internet draft, and it could be added at any time. That's why I'm interested in this subject.
Yeah, thank you. I'd read deeper into the document. Your concerns are really valid. I talked about this briefly yesterday, and the idea is that the current draft that I have is not something that works well with the idea of planned time. So that's not a scale that this works with right now. It just like 3339 works with instants in time, this is just in addition to that. So you can specify additional metadata that can help you, construct similar objects or information from the timestamp to relay, as you could say, important context with the timestamp, but not do things the other way around. I think there's a lot of interest in expanding this to actually include plan time. So that's something that probably needs to be answered once the working group regarding this is up and running. But it'd be really nice to have your input on that.
All right, Ira. Are you still in the queue, Ira? Are people still hearing me?
Sorry, finger fumble, didn't mean to be in the queue.
Oh, okay. Out of the queue then.
But I do think would be important to correlate this work with the work that Karsten and others have done on time in CBOR work group.
Right. That does make sense.
Yeah, thank you. I'd reach out to I think Kirsten or other people mentioned in the CBOR draft offline. And
the other thing is, I think if the working group gets chartered, I would ask that you keep this working group informed of it, just so we can follow along. All right. Anything else on this draft, or on this the report from dispatch yesterday? So next up is Doug Arnold. He's going to talk about some work to extend NTS for PTP. Doug, did you want me to share screen, or are you planning to do it?
Go ahead and share it. That seems to be more reliable.
Okay. Just let me get started. There we go. It's this one. Even with them all queued up, it seems to take me a minute or two to move between them.
Yeah.
All right, so there you go.
Okay, so if you've been paying attention to the email reflector, there's been some discussion on this topic. But what I want to do today is just sort of put it in perspective and say, what are we trying to do and why? So next slide, please. So there's been over the last few years an increasing call from network operators and people making PTP profiles in various committees are asking for a secure version of PTP. And in the last version that published, which is the 2019 edition of 1588, we did have a message extension called the authentication TLV, which could be used as a message integrity protection. And we had a little bit of discussion on key management, but that we didn't really have time to finish that. So we're taking it up again. And in the 2019 edition, we talked specifically about Tesla and GDOI. But now we're also including a discussion about extending NTS to cover PTP. So next slide, please. Okay, so there's basically two good reasons to have an extend NTS to cover PTP, and one is time server appliances that act as PTP grandmasters are typically also NTP servers. That's probably the more common than not. They're doing both, and so the implementation would be very efficient if you had something that was pretty similar for both timing protocols. The other thing is that I hear from network operators is, please don't make me deploy and maintain another key management protocol. They, and they're already doing TLS. Everyone's doing TLS because it's used for HTTPS and other things that are common. And so that's, another reason to do it. Okay, next slide. So it's, in summary, it's efficient for product manufacturers and it's efficient for network operators. Okay, now there are a lot of differences between PTP and NTP that make this challenging. The first of all is that most PTP profiles are multicast, not unicast. Most of them, of the deployments, have some or all of the switches and routers that support the protocol. And that's a major security challenge because now every device in the network is participating in this information transfer. Their PTP deployments are usually in small private networks. There are some exceptions to that, but that's by far the most common thing, and that's an advantage. Often the thinking in something that's behind a firewall, the security requirements are less than something that goes across the public internet. Message rates are very high. They can be 128 sync messages per second, and then there's other PTP messages as well, so you can have several hundred messages per second coming and going from the various nodes. Now, unicast PTP is client server mode, so it's the one that's most like NTP. But one thing that's different is there's sort of a negotiation protocol that sets it up, and then there's the PTP time transfer aspect of the protocol. And so that's kind of a key difference. And also PTP grandmasters keep state on all devices that they're synchronizing. So it's another difference. Okay, next slide. So those are things just to keep in mind as we're pursuing this. So we have a proposal we've been putting together in the 1588, and it's basically looks like this. There's the multicast version uses group-based security. It's very similar to GDOI, where there's a key server and everyone in the group sort of checks in and gets the same key. It's a shared key, and then they're periodically updated. And that's it's less secure in some ways than doing one-to-one, but it's practical for networks where every node on the network that's authorized is participating. And then NTS for unicast PTP, the approach we had outlined operates more like the NTP version. We put the exchange of the information that goes from the PTP slave going to the PTP grandmaster in what we are calling a ticket, and put that into the unicast negotiation part of the protocol, and then the time transfer messages, which can be at these very high rates, just use the authentication TLV. And then there's a cyclic updates for all participants to refresh their keys with the NTS key server. Next slide, please. Okay, so this is it's being discussed in the IEEE 1588 Security Subcommittee, which is also chaired by Karen O'Donoghue. That makes it easy to coordinate, hopefully. But what we'd like to do is move it here and make it eventually an IETF RFC. We think that this is the right place for it. There's more security expertise. This working group is familiar with NTS. And if you want to keep NTS for NTP and PTP coordinated, this is probably the best place to do that. So this is just kind of a summary, what we're trying to do and why, and there's going to be proposals submitted and discussed and debated. But this is what we're up to. So any questions?
Go ahead, Daniel.
Dealing in the multicast case here, so you're talking about a group keying protocol. If it's simple, then that implies that the clients have to implicitly trust each other because they all share the same keying. We're trusting the switches and routers to behave correctly as part of the protocol. So what's left is our threat model here. What is untrusted that we're protecting ourselves against?
Well, we're protecting ourselves against someone who gained access to the network, but hasn't necessarily taken over any device. No, it's not necessarily a man in the middle of attack, but they've gained access to the network, and PTP is especially vulnerable to that because they have this best master clock algorithm where there is one best master, and it's based on self-proclaimed credentials. And so if someone just gets access to the network, they can take it over.
So are we permissioning clients? What prevents the adversary from just joining the group and getting access to that group keying material?
Yeah, I mean, there things that are open-ended are, you can run an authorization protocol as well. So if someone tries to check in and say, I want a key for this group, and the key server can refuse. And then you don't have the right key, so then you can't make the right checksums, and that's the threat model. And this sort of thing has been used in real networks. It's used in the power grid. GDOI specifically has been used in the power grid to secure some of the SCADA system messages, like Goose messages.
I mean, I'm not challenging the suggestion that if this is specified, it will get used. My question is more along the lines of, is it being used for actual security, or are we just creating a compliance talisman for people?
Well, you know what? Oh, so go ahead, Doug. Sorry.
A compliance talisman.
Well, there's definitely a call for security. People want to secure PTP, and that we've had a lot of discussion on what do we do with a network that is every switch is a transparent clock, and they're all altering the messages as they go through. Are we going to have a lot of secrets, or are we going to have one secret that is shared among authorized users? It's neither one is perfect, but it's a kind of a worst case scenario in terms of trying to secure a protocol, because it's not a conversation between two nodes that is just being moved through switches. Every device is part of the conversation.
Yeah, I mean, and I guess my position on this is the same as it's been for years. That you're absolutely right. It is a worst case scenario, and I think what that forces is just a fundamental trade-off. If you trust everything and everything is behaving correctly, then you can get a lot of precision benefit out of PTP. But if things are behaving incorrectly, then then what you're ultimately going to get is something that basically falls back to the bounds you get out of NTP, and no amount of crypto is going to save you from that trade-off.
All right,
I
Dennis?
don't think I completely agree with it. I think there are attack modes that a group key could help with. And the one I mentioned is because of this, NTP has, you can ask lots of servers for time, and you can run a voting algorithm, and you can detect that, one of them has a problem. In PTP, that's allowed, but generally not done. And so they are vulnerable to that, a device just getting into the network, even if they haven't taken over any switch. If they've taken over a switch, they can do all kinds of things, and maybe messing with the time isn't even the worst one. But if they just get access to the network, but maybe they can't get the group key because they're not authorized, and that would be something that would be better than doing nothing. And then there's the unicast case, where if you have unicast, then it can be more like NTS for NTP. And there are a lot of networks where you have unicast and you don't have on-path support. So it's more of an end-to-end point-to-point conversation, and it can be more highly secured.
Yeah, I mean, I think the more it's shaped like NTP client server mode, the easier it becomes to secure it with something NTS shaped. But I'm not sure there's any point on that spectrum where just use where either continue using unsecured PTP or use NTS secured NTP. I'm just not convinced there's any useful middle ground there.
All right, Dennis? Dennis, did you want to?
Hello,
Are you
can
muted,
you hear me
Dennis?
now?
Yes.
Okay, sorry about that. I did also want to point out that I think there is some agreement that when it comes to securing time networks, that the time itself is not necessarily what we're securing, because the time is a fact of the moment, and that it's really associations we're securing. And so in this case, the focus is going to be on a secure PTP network, making sure that no PTP clients attach to unauthorized masters. If an attacker gains control of the network and simply participates on the network as a timing client, they're not doing that much damage. It's really protecting that association between all the clients on the network and whatever is serving the time. That I think is going to be the focus of whatever security comes out of the PTP group. Because as Doug observes, the PTP best master clock algorithm was not designed with security in mind. And it can be easy for a rogue attacker to simply broadcast better BMCA credentials, and now all of a sudden all of the multicast PTP elements are taking time from it. So I think what's being secured here is that time association with whatever is providing the time.
Okay, next in the queue, Christoph. Oh wait, Doug, did you have anything you wanted to say, or?
No, I completely agree with Dennis's comments.
Dennis, okay. Christoph?
Is this working properly now, the audio?
Yes. Yes, we can.
Great. I was just going to add that I don't think we should see PTP use cases as set in stone. At this point, we see popping up more and more that people want to use PTP over like long landlines or in scenarios that it hasn't been used before. So maybe also just the generic aspect of future proofing would be smart to think about here, instead of seeing it as a given that PTP is always used in like completely controlled networks, as it largely is now.
Yeah, I think that's a good point, and I think that's part of the reason we are proposing these two different modes. You know, one for this kind of small little private network, and the unicast version that can, you know, serve some of the applications in that category you just stated.
Okay. Any other questions on this draft? So Doug was the primary developer of this is Martin. He was unable to be here today. So thank you, Doug. I think we sort of asked you at the last minute to do this. And there is a 0.0 draft that has been posted. And there's an update coming, right, Doug?
Oh yeah, there'll be updates, and there's already a counter proposal on some of the details. So yeah, we'll be discussing this.
All right. All righty. Any other questions on this topic? So with that, the next one on the agenda is the next topic on the agenda are the NTPv5 drafts or the NTPv5 discussion. The way we thought we would organize this is James has done a requirements document, so you would be first, James. Let's see.
Well, could you
do you want me to do your slides, or?
Yeah, that's probably more reliable.
I'm not entirely sure of that, but let's see. Application window. All right.
Excellent. Okay, so next slide, please. So a bit of a brief overview of what this is. So last IETF, I think it was, Karen and a few others discussed the idea of having a requirements document to at least collate the various things that people were interested in fixing with regards to, well, in terms of the design of NTPv5. I know that there is a lot of people have got a lot of different ideas. So I set forth and went through track, and I went through as many different things that I could find that have covering the various issues with NTPv4, and as well as some of my own thoughts about this, about what NTPv5 could and couldn't have. And so the whole point of this is to start that discussion and get some consensus on some of the difficult points. I know that we've been, since the last interim, had quite some robust discussion on points around security and timescales and so on. Next slide, please. So I've currently got two versions of the draft out. So I've got an 01 out at the moment. I've got a few editorial changes sitting in the GitHub repo. Just a recap of what's in the document, if you've not read it. It puts in requirements for a new linear timescale, so no leap seconds in band. It supports, or at least aims to support, both UTC and TAI representations. And leaves room in extensions to potentially support other timescales. I think the least controversial thing that is there is separation of steering algorithms away from the protocol specification, authentication as a requirement with optional confidentiality, as well as some statements about backwards compatibility, taking into consideration ossification, which I think it was Yuki who brought up on the list not too long ago. As well as some extensibility. And there's a few other, next slide please. There's quite a few things that have not yet been covered, but some of these are issues in the GitHub repo. Some of these are just on my to-do list. These things include what might be put in requirements to deal with DDoS and NAT, as well as putting together a threat model to at least describe the kinds of things that we will deal with or won't deal with, which I think will be a critical part of dealing with the security aspect of the protocol design. Last slide, please. So I am opening this up to a discussion about, next slide, please, Karen. So I would like to open this up to, should we be considering adopting this document? And what sort of process should we be using to apply to the protocol design? I would like to just leave that open to people, and I'd like to hear what people's thoughts are.
Okay, Yakov? Actually, okay, go ahead, Yakov.
Okay, if I'm already starting. I apologize for not having read this document. I will do so. I just wanted to mention that some work was done on a similar topic at the beginning of TikTok quite a few years ago, but Kurt and Peter came up with a document which they called ITP, which was supposed to be the next version of NTP, and it's worthwhile to see if there's anything in that document that might be of use.
Ooh, I was unaware of that. Okay, I will put that on my things to read list.
Yeah, when the TikTok working group first started, and Stuart and Yakov were chairing it, the charter was actually to do a requirements analysis and a gap analysis between NTP and PTP to see what the next generation of time synchronization protocol should look like. So there is some, it was a more open-ended, what's the next thing? Yeah.
Yes, but there is a document with requirements.
Yeah,
I can find it. I remember they called it ITP in order not to call it NTP.
yeah. There was that document. That was there another requirements, like an actual requirements document that, like the beginnings of the gap analysis. But anyway, really old TikTok documents.
We actually had an interim which we went and we put together a gap document. I do not recall if it came out as a draft, but I probably could find it if I look around.
Yeah.
If you could, that would be greatly appreciated.
Doug?
Oh, sorry, got unmuted there. Okay. Yeah, I would say I think it would be very helpful in the development of NTP version 5 to have this document go forward. There's lots of ideas being debated, lots of passion, and if we can agree on the requirements, then I think we can help sort of rein in the discussion and say, let's go forward in that direction, and we have a much better chance of converging.
All right. Daniel?
Yeah. So I think something of this shape should go forward in some form. I'm not sure whether we really need to advance it as an internet draft, though. It's just, I know this is something that happens all the time in the IETF, but it's something that I grumble about every time I get a sector review of one of these. That I don't see that this is going to have any archival value once we have an actual working group specification document adopted. So maybe this is something that that should just go into the wiki we've started and maintain it in that form rather than have it as a formal working group document.
So I hear what you're saying. I guess the thing that I'm wondering about is we've just had the counter example to that, where a draft that was done, I don't know, 13 years ago, we have just said, wow, it would be really good to take another look at that. So I think there is archival value. Yakov?
Yes, I saw one point, is I'm getting into technical things and maybe this should be brought to a list. But there was a point there about separating the steering from the protocol. I remember one of the topics that we discussed at the time was the fact that NTP, unlike PTP, has a lot of these dispersion parameters and things of that sort in the packet because of its client-server rather than master-slave architecture. And that would be something, we didn't actually get into it too much at the time, but everyone realized that was a part of the problem. It would be interesting if you could have a separation, that is, have a document, have a protocol which does not go hand in hand with the algorithm which is used for the stabilization of your clock, even when it is restful. That is pure client server where the server forgets the client.
Okay. That does seem like something that we should discuss on the list. James, did you have anything you wanted to say specific to that?
No, nothing specific. That makes sense. That's certainly a discussion we can have on the list.
Okay. Daniel, are you still in the queue, or is that a queue fragment? And you're out of the queue.
Sorry.
All right. So the next thing is, and we don't have slides for this. So Miroslav has put together a draft proposal for NTP v5. Miroslav, did you wish to speak to that? Or would you please speak to that?
Yeah, sure. There is a new version of the draft that I uploaded. The concept hasn't changed. It still looks mostly like the NTP that everyone knows. It's trying to address the issues that we have described and that I thought we were set on addressing, but from the discussions we had, it doesn't seem so. So in this version of the draft, there were no changes in the protocol. There were some general improvements. There is a full description of the correction field now. Doug helped me with this. There is a new section on the measurement modes. There is still a lot of things missing to make a full description of the protocol. And before trying to finish this, I think we need those requirements. From discussions we had on the mailing list, I think it's clear that some people want something very different, and we need to agree on what that should be.
Okay. Are there any questions or clarifications for Miroslav in what is in his current draft? Okay. So thank you very much, Miroslav. I mean, we did ask, one of the keys for the IETF is that we need contributions to drive our work. And so I'm really interested in what implementers are interested in implementing, and also what vendors are willing to put into products. And so go ahead, Yakov.
Just a short comment. I'm trying to read the draft right now. Once again, my apologies for not coming, having read all the drafts. I can't sit on one of the front 2 rows of Meet Echo here. However, it looks very nice. Yes, there are some gaps in it, and it is definitely a small increment as compared to NTP, but it looks like it's a good solid version.
Okay. Doug?
Yeah, some of the other things that people want to do with NTP, I think a real virtue of what Miroslav has started with is something that's very flexible. So it can do all the traditional NTP. You can get time over the public internet from a pool, but you can also do some kind of niche application in some cyber physical system that people now are already doing with NTP packets, but not the rest of NTP. And so I think it's got the best of both worlds. It's got the flexibility to do all the different things that people want to do with NTP.
Okay. Any other questions or comments? Watson, go ahead.
Speaking as an implementer, yeah, I don't know that much about the details of the PLL, but so whatever comes out of this process, whatever, it's not really going to push one way or the other unless there's look at this draft, look at the other proposals, they both look the same to me. One thing, did you say anything about the PLL stability discussion? There's this long thread on the mailing list about this particular thing and whether or not you need to transfer frequencies separately and the impact there.
Miroslav?
I'm sorry, I didn't get the question. Like, if this should be included in the draft, this discussion?
Yeah, there was this discussion about the impact on stability of, do you need the frequency, or is it a consequence of, or does it only help if your PLL is otherwise mistuned to track more aggressively than it should?
Yeah, I think it does help, but it doesn't help always. So it depends on the PLL. But if you want to minimize both time and frequency error, and you don't have enough data, like the polling rate is not sufficient, you need to transfer both time and frequency separately. Yeah, but I don't think this should be discussed in the draft of the protocol. I think the protocol should just be exchanging timestamp. That's all it is needed. And it's up to the implementation to decide how the clock should be controlled and what is the goal, to minimize both time and frequency error, or just one of them. I think in the NTPv4 specification, there is this PLL, FLL algorithm that works, but it's not always, it doesn't always meet those requirements. So it's clear that people need something else in some cases, so the specification shouldn't prevent that.
Okay. Daniel?
So before we go forward with adopting any draft specification, I think there's one really contentious issue that last I looked seems to be splitting this working group about cleanly in half, which is whether or not NTPv5 should support any unauthenticated mode of operation. And I think we should probably get a formal consensus call on that issue before we do much of anything else, because that's going to be a real blocker in determining some pretty basic things about the structure of the wire format.
Yeah, I think that was part of the Miroslav saying that we needed to advance the requirements a little bit before we adopted the draft. So I think that'll happen as part of that. Yakov? Go ahead, Yakov.
Can I go ahead? Okay.
Yeah.
My comment is actually about the previous discussion, the requirements one, but it was triggered by the discussion of the PLL. I think in any requirements document for a new version, especially one that's going to be doing other kinds of use cases, the discussion of what you do or how you can exploit the fact that you might get frequency from some other source and not from the time itself, such as which is being done in telecom networks, where you use sync-E to get frequency and then 1588 only for the time. I think that's a discussion which is worth capturing in a requirements document.
Okay. James?
One of the points that I failed to mention when I was presenting earlier, because I turned into a ball of nerves, was that the requirements that I have in this document are not set in stone. They're just my collection of things. And so if the working group wants to reconcile, have a different view as to Daniel's point around security requirements or whatnot, and there is consensus, then that's completely fine. So the call for the call for adoption on the requirements document is not necessarily a call for adoption on security. It's a call of adoption for a document that specifies the requirements of V5, and we can decide either before or after whether or not we want to actually have that requirement.
Yeah, I was thinking of the call for adoption on Miroslav's NTPv5 document. I think the answer to the security question might need to be addressed in the requirements document. Sorry, Karsten, too many moving targets.
Yeah, thank you. I have a simple point of information. I just leafed through the document, and it mentions leap smearing, and I'm wondering, is there something like a convergence on the right way to do leap smearing already? Just a question.
I don't feel there's a convergence.
So, I think the answer to that is sort of what Google calls their standard smear of 24 hours noon to noon. Linear smear seems to be trying to assert itself as something like a convergence. I think this working. So I think this working group is probably has more power than anybody else to turn that into an actual convergence. But that does feel like the direction things are heading right now.
Is that something that people actively pursue, or is it just in people's minds?
It's, I mean, it's in my mind. Other people can speak for theirs.
James?
I'm desperate to get rid of leap seconds for all the pains that they've caused, or at least putting them in separately from the time information so that they can be handled separately.
I feel like I have scars from leap second discussions. I first got
I
involved in
think
trying to
most
get rid
people
of
have.
them.
That's why I was asking. The document just mentioned them as if they were a done deal, and I just wanted to know whether I have missed something, because I haven't been to an NTP meeting like in 10 years or something. Okay, that answers my question. So with that, let me just make my ceterum censeo here. Of course, any new protocol that has extensibility should use CBOR for the extensibility. But I'll shut up now.
Doug?
So enough people who work for large companies that have large distributed databases have told me they want to do leap smearing that I've given up on talking them out of it. I think it's just going to happen. Whether it's a good idea or not, I think the justification for it is that it's easier to mess up the time than it is to get all the database code to handle leap seconds correctly.
Yeah, I mean, I don't think there's that much controversy about that part. There are always going to be applications that want to be able to just assume that there's 60 seconds in a minute and take smeared time. But I think what this working group needs to address is whether is what NTP should be carrying on the wire versus what is just a translation performed by the NTP client for the view of the rest of the operating system.
Yeah, well, I think that what's in Miroslav draft is he is making smearing visible, so you can see, yes, it's turned on, there's a flag for that, and as well as some additional information. So I think that's should be part of NTP version 5.
My view on that is that the NTP packets should carry all the information necessary in order for the client to perform a leap smear, but we should not actually be putting smeared timestamps on the wire.
Go ahead,
I would agree with that.
Just wanted to agree with that statement that not put the smeared timestamps on the wire.
All right, so enough about leap seconds. Harlan. Did you mean to raise your hand, or can you join the queue? Can you turn on your audio?
Sorry about that.
That's all right.
Yeah, figuring out icons is always fun. Expecting clients to be able to handle leap smearing is naive. So there are certainly completely valid use cases for putting smeared time out in an NTP timestamp.
Go ahead, Yakov.
And there are really, really good applications where it's a terrible thing to do.
Go ahead, Harlan, you're still speaking.
That may be, but what we're now talking about is policy, and whether or not it's a bad idea is something which is decided as local policy. The ability to do something about possible smeared time is a mechanism question, and that goes to the protocol.
Okay. Oh, Watson, go ahead.
Too much time with, but I think the clients can, the client implementation can compute the smear and adjust the clock locally. It's more of a problem for servers where we have, if you start changing the system clock and you're depending on packet timestamps, it's this whole huge mess. So it's, and that's probably not really a working group thing so much as a people implementing this, working with operating systems to try and get the interfaces we need to implement smear time and NTPv5 on the same systems, if that's something that people end up doing.
So what, Harlan, what you were saying is something that you would want to do to legacy v4 clients, right? It's not really a consideration that would go into the design of v5.
I'm not sure I understand your question, Karsten.
Well, you just said there's a use case for leading clients through a leap smearing event.
I'm saying that there is a big class of clients that will not be able to decide whether or not they wish to smear leap second time. And therefore, there is a significant use case where clients must be told to use leap smeared time so they stay in sync with other devices in the network. So the decision as to whether or not you feed smeared time to somebody is a local policy choice. And there are trivial ways to make sure that the time you give somebody could be smeared or not based on what they're telling you. So this doesn't have to be complicated, and from everything I've seen over the last several years of coming up with proposals around this, it's not that big of a deal.
Okay.
Okay. Where am I in the queue? Daniel.
Harlan, this configuration of clients thing, telling them what kind of time the system should use. That sounds like something to put into DHCP, not directly into NDP.
That is certainly a choice, but again, that's going to require clients running updated software, and that's something that if somebody decides is a really good idea, and it really is, well, then in 30 years we'll know if they were right.
Yeah, of course we need them running updated software. Otherwise, they're still going to be on NTPv4. Anything implementing NTPv5 obviously has to be updated.
Well, yes, but an NTPv5 server is going to be talking to NTPv4 clients for decades.
Of course, but it'll be speaking NTPv4 to them.
Yes.
Okay. Doug?
Yeah, I just want to echo that. I think the right way for an NTP5 server to respond to an NTP4 request is with an NTP4 response, not to mix them. And if it can't, then just drop it.
All right. So we actually had one more presentation. Doug had put together a presentation kind of looking at the mailing list discussion and Miroslav's proposal and sort of like key issues and a way forward. And I probably should have moved to that a little bit before now. Daniel, did you want something else on this, or do you want to? All right. So let me get these slides up. Application window, key issues.
I did put this at one point on the email reflector, so a lot of you have seen it, but I just sort of gathered together some of the issues that were being debated on the email reflector. Next slide, please. Regarding what NTP version 5 should be. I think this is just a statement I'm going to make. NTP version 4 works very well for most NTP applications as sort of a general IT use, and we need to preserve that. Everything, the startup issue is not solved, as we know, but everything else works really well. So this has to be preserved. Next slide. So the question is why are we doing it? Greater accuracy, flexibility for other kinds of use cases, mandatory security to push users to adopt security. That's something that has been proposed, as well as uniform monolithic timescales like TII to avoid time leap seconds, at least in the timestamps, and simplify NTP world by moving everyone to client server mode, which also has some security advantages. Next slide. So these are things that people had said these are what NTP version 5 should do. And I think at the time when I did this, I think this was what I found in terms of the requirements draft had the flexibility, had the mandatory security, the monotonic timescale, and the draft so far by Miroslav had the improved accuracy, had the flexibility as well, and client server only mode. So there's some agreement, but also some differences between those two. Next slide. To improved accuracy, this is very important for certain applications. There are people who tell me they want to get 50 nanoseconds with using NTP. And this is generally in financial networks. And so they take the NTP VOR packets and they throw out everything else, and they basically do high message rates like PTP and specialized algorithms with things like lucky packet filters, etc. And they are able to do pretty well. And I would point out also that the Miroslav's draft does have correction fields that also can help with these kind of high accuracy use cases. And these are usually in small private networks in one subnet typically. Okay, next slide. Okay, flexibility, again, for these kind of specialized use cases. When you detach the algorithms, then things like Chronos also becomes just another set of algorithms that goes with the NTP protocol, as well as these high accuracy things and some other, whatever else people want to do for some specialized application. I think it might make sense to have an informative document at some point saying, hey, if you want to get the general IT case to work with a very good set of algorithms, here's an outline of how they work. Okay, next slide, please. A mandatory security. There is some precedence for this being, pushed into new versions of protocols, and people grumble at first, and then eventually everyone's saying, well, of course we have to have that. Maybe there's some niche applications that aren't going to want that. I think it's more likely that there will be some niche applications that might want a different version of security. So I think that's probably what we are going to want to look at to maintain the flexibility that we've started enabling, is to say, okay, here's the default security mechanism, and here's a couple of others that have been, that can also be used if you have to use one of these. So something like that is a possibility. I also want to put out, security tends to change all the time. There's new threats, new capabilities among the threats, and so new algorithms, and these things are always changing. So I think it might be easier to decouple them in terms of documents. Like the base document says you will use one of these, and that's a list that can be just maintained easily, and then the other things are developed separately. Okay, next slide. Monotonic timescale. If we're going to do a monotonic timescale, it really should be TAI, because that's an international standard, not something like that, like GPS time or something that doesn't necessarily always make sense. So, and that no leap seconds in the protocol, that's really an overstatement, because you can do TAI timestamps that still have a UTC offset. That's exactly what BTP does. And if you want TAI time, you can ignore the UTC offset, and it's monotonic, but you can also get UTC, which is basically required. It's in legal requirements. It's in a lot of technical standards. You have to have UTC. So, but there are other niche things where people want UT1 or some other things. And one of the things that's in Miroslav's proposal is you can select other timescales and just let people know. That could also be handled with timescales always TAI, but there's a field where you can put the offset to whatever you want it to be, and you just say it's an offset to UTC or UT1, or there's some other ones as well. So I think I don't think we're going to get away from people wanting to do other timescales. Okay, next slide, please. Okay, unicast client server only. Most deployed NTP devices do this. It makes the protocol simpler and helps with some security issues. And we don't have a security standard that's up to date for the other modes, so that's another issue. Some of these modes people are using and they're happy to use, but maybe we could say that's fine. You just keep using NTP version 4. But there might be desire for some niche application to do something quirky. Okay, I think that's the last one. So these are just things that were being debated. I just saw them. There was discussion on all these things, so I kind of gathered them together in one place and say these are issues that we need to make a decision on.
Okay. I guess go ahead, Karsten.
Yeah, Karen just asked me on the Jabber, and it's maybe easier to just say this. So there was the observation that the security components are always changing around you. And one strategy to deal with that is to actually offload that to some activity that already has maintenance. And one such activity is COSI. So we have a algorithms registry and all this stuff in place that is moving forward, in particular with algorithms that make sense for IoT devices. So maybe that's a component you may want to look at for doing security in V5.
Okay.
I'd like to comment on that. I've had a lot of discussions with security people, and if they're not familiar with timing, they say a lot of things that don't make any sense for timing protocols. Time is not data; it's a signal, and it's different in a lot of ways. Two times that are very close together but different slightly different are basically the same, and that's not true of data. There's just lots of little differences, and I think any security for a timing protocol is going to have a healthy dose of timing people involved in defining it.
Yeah, I think that there are different levels here. The actual security protocol that you are using, that will be very timing specific. But the lower level components, like identifying hash algorithms and all this nitty gritty stuff, that you can get from a standards activity like COSI.
Agreed. And we should not be trying to develop that kind of stuff ourselves.
Okay, Dennis?
So since it's late, can you hear me?
Yes.
You know, we've had a lot of discussion about the leap smearing, and I know there's been some discussion about whether or not security might be mandatory. Without rehashing all that, I'd like to maybe suggest a different approach, and that might be that do we want to consider for NTPv5 making a different set of recommendations for servers that are meant to be connected to the broader internet than we would necessarily for servers meant to be used on a customer's closed network? And maybe over the broader internet, we make much stronger recommendations about security. And in a domain where the customer has more direct control over what attaches to their network, allow them to be somewhat relaxed.
Watson?
I just want to comment on the recommendation thing. What's the Cloudflare? It is not the way that IT security is going. More and more, the local network is untrusted, and its specific authorizations, the same you would do as operating over the internet. And more companies are in the position where they don't have a network. They are using services online, and so I think the relevance of a closed network security environment, that's less and less relevant.
Okay, James, really quickly, because I just realized we're running out of time.
Yeah, really quickly. My concern with having like a best practices or something to describe that is that it'll be a serving suggestion, and then we'll end up with more insecurity. So I can't say I'm a fan of it.
All right, Watson? Or are you left over? Harlan? This is the end of the queue. Go ahead.
There's still a significant use case for people on networks to not to use security as part of every packet. And I would say that it is not interesting to a lot of people here, and it may not be appropriate for a number of use cases. It's not appropriate to all use cases, and I don't want to see us I don't want to see us change a policy choice into a mechanism choice or into a mechanism issue.
Okay. So the next item on our agenda was to talk about chartering. We do need to work on a working group charter. I'm going to defer that to our virtual interim, what's coming up. Dieter has worked on a very rough draft of a charter, and we will get that out to working group to discuss. And before I do the discussion of virtual interims, any other business? And I know that there's one item that's any other business.
Yeah, so I just
did we just lose him? Oh, Daniel just went offline. Well, that's really bad timing. So while we're waiting for Daniel to come back online, there's a lot of time between this meeting and the next IETF, so I think we need to work really hard to have at least 2 virtual interims in that time, because I think we have a lot of work to do.
Sorry, I'm back. Sorry, I meant to hit control V and I hit Control W instead and close the tab.
Okay, welcome back. Go ahead.
Yeah. So I just wanted to put in a quick plug for BizTime. Link now in chat. So I mentioned this on the mailing list a couple of weeks ago, and I know people are looking at it because the GitHub repo keeps on piling up stars. But as far as actual feedback, I've gotten crickets. So BizTime is Byzantine fault-tolerant time synchronization between a group of peers, when all you care about is keeping those peers in sync with each other and advancing at something very close to 1 second per second, without caring about whether this drifts in the long term from any authoritative time source like TAI. So this has been in what I have now for this is an implementation. It's a good, robust, secure implementation. It's been in production with us for about a year. I do not have a draft at this time. I'm planning to write it up as an experimental track ID. Since there aren't really any other stakeholders that I can identify at this time, I'm planning to do this through the independent stream rather than as working group draft. Obviously, if significant interests picks up, then we could circle back and pursue something standards track. But anyway, at this time, I'm just interested in hearing from people if you're using this, or even if you just have any theoretical applications in mind other than that I haven't thought of. Just want to keep people in the loop.
Okay. This was sent to the mailing list. I don't know if you want to send a reminder. And I don't know if This Is Great stuff is the NTPv5 stuff or the BizTime, Watson, but or both. Maybe it's both. All right. So like I said, I think we need to have a virtual interim, looking at the weeks of April 13th or April 20th. If anybody has any major conflicts that we should try and avoid, please send them to Dieter and I, and otherwise we will try and get something scheduled and on the calendar. We have several things to do coming out of this meeting. With that, I look for the virtual interim announcement, review the drafts, and keep the conversation going. Anything else? Harlan, you're not still in the queue, right? You're just... Go ahead, Doug.
I'm in the queue.
Yeah.
Oh, never mind. Wait a minute. Harlan's in the queue.
Okay.
Oh, wait. Harlan's gone. Maybe Harlan's not in the queue. Go ahead, Doug.
I see the week of April 12th through the 16th is an ITU meeting.
Yeah.
Oh, and the week after, it's a 2-week meeting. So I just thought I'd mention that. That could be a conflict for some folks.
Right. We could go to the week of April 6th, if that's the week after Easter, but I guess since it's going to be virtual, it may not matter as much. And that's 1, 2, 3. 1, 2, 3. That's only 4 weeks from now. Okay, send us your comments on scheduling and we'll see where we end up. We're now 4 minutes over, so I guess I should probably end this. And with that, I think we're done. Oh, wait, I see another chat. Oh, more of that. Okay, with that, we're done. Thank you, everybody, very much. And we will see you when we see you.